We are back. We need to do hurricanes and tie up this weather unit. Hurricanes, by definition, are very large cyclonic storms of tropical origin with sustained winds of at least 119 kilometers per hour. Hurricanes are the name given to these storms when they originate in the northern hemispheric Atlantic Ocean and the eastern northern hemispheric Pacific Ocean. In the western northern hemispheric Pacific, these storms are called typhoons. And in the western southern hemispheric Pacific Ocean, these are called cyclones, and they rotate the opposite way. So in the southern hemisphere, cyclones rotating the opposite way clockwise. For us in the Atlantic, the hurricane, named after probably an old Carib Indian god, maybe Mesoamerican god, Huracano, the hurricane season lasts from June to November. If you ever get a chance to read the Mayan origin myth called the Popol Vuh, they mention this god in translation, Huracano. Hurricane Katrina right here, spinning cyclonically, counterclockwise around its eye. The eye here in the middle, the eye wall on the outer edge of the eye, the strongest part of the storm at the eye wall, the center of the eye, calm. Cyclonic winds moving in cyclonically to the low, and then you have these bands of rain, which are really bands of thunderstorms stitched or quilted together. Here's the diagram of where you could find a hurricane. This is our region, starting actually over here in Western Africa. And then these storms track into the Gulf of Mexico, into the United States, do their damage along the coasts of the Gulf, Western Florida, the Panhandle, up the East Coast of the United States, all the way up into Canada. They can cause problems. They can, even if they track over the ocean, land. Last year we had a hurricane that made it all the way up to Ireland. Most cyclonic storms, again, they're forming within this region 10 to 30 degrees above the equator on either side of the equator. So then if it's in the southern region, it would be a cyclone, and then over here in the western Pacific, typhoons. Again, the season for us is June to November, a little bit longer in the western Pacific, Eastern Pacific, off the coast of Mexico and North America. And then winter for us is the tropical cyclone season in the southern hemisphere, and then a slightly longer season in these more subtropical regions where the ocean must be staying warmer longer. We start with a little zone of low pressure, a depression that develops cyclonic wind activity, more and more warm, moist air evaporated from ocean water that's over 80 degrees Fahrenheit. That's what's driving hurricanes. That is the fuel of hurricanes. Hurricane fuel is warm ocean water. You can think of a hurricane as a quilt of hundreds of individual thunderstorms rotating counterclockwise around the center of very low pressure. They spin in accordance to the rules of air movement in the northern hemisphere. Clockwise movement, remember, leaving a high, and for a hurricane, counterclockwise around this, then in a hurricane, zone of extremely low pressure. Again, counterclockwise in the northern hemisphere, and then if we drop down into the southern hemisphere, we would have a cyclone spinning clockwise around a center of a low. Hurricanes have a center, again, of extremely low pressure. Air is drawn from hundreds of miles around the storm towards the center of the low, rotating counterclockwise around the low in the northern hemisphere. Air passes over very warm ocean water, greater than 27 degrees centigrade, that evaporates and fuels the storm by rapidly rising, expanding, cooling, condensing, releasing latent heat, and driving that hurricane forward into the future. The strongest winds always in the wall surrounding the calm eye or center of the storm. Here would be a pressure map from Hurricane Sandy, just to give you an idea of how the pressure can drop And this isn't even very low. Here the pressure is down around 960 or so. You can have a hurricane of Category 5. Remember, Sandy was a Category 1. We'll get into what that means in a second. But with a Category 5, you can have air pressure below 900 millibars. So low that it's drawing air in at a faster and faster and faster speed over the surface of the ocean. And of course, that air that's being drawn into the low is carrying with it more and more water vapor that can rise, cool, condense, and release latent heat. And again, eye wall, eye, spinning counterclockwise, spiral rain bands. Track of a hurricane. Hurricanes move over the ocean, being drawn and directed by zones of air masses that can block high pressure air, that can block lower pressure air, that can draw the storm up, say, the coast of the United States or into the Gulf. And you might notice this shoreline shape here. Why do you think this shoreline has this shape? Because counterclockwise air rotation has ground out the shoreline over thousands of years. Same in this region, same even here. So hurricanes have a long-term effect on shoreline shape or shoreline morphology. And if we follow this track, we also note how the hurricane changes over time from a subtropical depression when it's blue to a major hurricane when it's purple. Again, if you go to the National Hurricane Center, www.nhc.gov, you can find out their predictions for a particular storm. And this would be a classic diagram for wind probabilities, wind speed probabilities. This was for Hurricane Dorian last year, and this is the hurricane that famously President Trump decided to draw his own forecast all the way over here to Alabama, where no one really expected any problem from this storm. Of course, he then defended his move and got mad at the people who are scientists and know better. Here's a hurricane from 2017, Hurricane Irma. And this is an interesting thing to look at because it shows how many different potential tracks a hurricane that forms could take. You can see how the track narrows as we get closer and closer to where the storm actually is. But as we go further out into the future, 1 and 2 and 3 and 4 and 5 days, we have a wide range of potentials that a storm can take. And this red here then illustrates where the storm finally did go. And people spend a lot of time all over the world trying to predict where storms will go because they're so powerful, they can do so much damage that we need to get people out of their way. Here again is where Hurricane Irma finally went, and here you can see the changing strength from light blues or aquamarines to the darker reds when the storm was at its strength, passing through the Bahamas and over Cuba, and here over Puerto Rico here, and here Dominican Republic and Haiti. Here's your Saffir-Simpson hurricane wind scale, air pressure scale, and storm surge scale. Tropical depression is the lowest wind speed. We don't really worry about a storm that's a tropical depression. Tropical storm itself, the winds are getting high. 73 mile an hour winds or 68 mile an hour winds, that is a high wind. Now we're into hurricane categories 1, 2, 3, 4, 5, characterized by their range of winds, their millibar pressure, and their storm surge, the potential for them to lift ocean water as it approaches the shore and flood the land. Here, the water would be 4 to 5 feet above normal, 6 to 8 feet, 9 to 12 feet. This is 13 to 18 feet. This is what we had in Sandy. We did not have it because it was such a strong storm. It's because it came in at high tide on a full moon. And of course, here, greater than 18 feet. And then again, some of the more specific damages that you could look at by pausing this video. I won't go through all of them, except to say that when we get up to the highest category of hurricane, we're talking about complete destructions of homes, the complete destruction of homes, shopping centers, trees uprooted, extreme flooding, power and water potentially out for months. Billions of damage, billions of dollars of damage done. And, you know, if you've followed the news in the last year, you know there was a major Hurricane Marie down in Puerto Rico that the federal government, normally under an administration that cared, would have helped in a major way. But those people are still suffering the consequences of that hurricane. And this is a problem with hurricanes. You need to then rally the nation financially behind getting people back on their feet and fixing infrastructure. The greatest damage caused by hurricanes happens as they approach the shore, which just makes sense. Storm surge causes flooding as the dome of water develops near the eye of the storm. This, combined with a high tide, can raise water level well above normal. Surging water can pick up rocks, boulders, wood, objects, cars, and hurtle them through the water, which then crashes into your house, and that's not very nice. Can move tons of sand. So then that's number 12. You're going to answer, what is storm surge? Well, look at what it does to these houses. Millions of dollars of damage for these people. Billions of dollars of damage here. This might be Hurricane Andrew. Look at that flooding. People's property damaged. Hurricane safety. We've got a hurricane watch. You got 36 hours now to get ready. Start boarding up your house. Start taking care of business. Figure out what you're going to do. Are you going to leave? Do you live right on the shore? Could storm surge impact you? You need to be aware of the hurricane watch. The hurricane warning says this is happening in the next 24 hours. If you're not gone already, you probably have to wait that storm out at home, and you better have a place to go. Now, unlike a tornado, you do not want to go in the basement during a hurricane. You need to be up high, but you need to be protected from wind and flying objects. So here's the thing, some of the things you can be doing before a hurricane. Having a pet plan, boarding up your house. Make sure that you know where your valuables are, where your evacuation routes are. Have enough supplies so that you can have at least 3 days without being able to get stuff at a store and without the government bringing in supplies for you. Make sure you have gas in your car if you need that. Turn off your electricity. Have a radio that doesn't require power but has some kind of like hand device to power itself, or solar, something along those lines. During a hurricane, again, don't go anywhere where there could be flooding. There can be 15, 20, 30 feet of water and you're suddenly drowned. Get out of structures that aren't strong. Try to evacuate if you can, but if you can't, all the best. After a hurricane, you need to be careful before you go back to the area to make sure it's not so damaged that you could get hurt from just the effects of the flood, downed power lines, leaking gas. Don't drink tap water until people say it's okay. If you want information on a hurricane while it's happening, the National Hurricane Center, your government's source of information, it's where everybody gets their news about hurricanes, so you can just go directly there. Then they also have some good information about what hurricanes are, how they form on their website, and I left that here as well. Finally, number 13 in your little assignment is to compare and contrast hurricanes and tornadoes in terms of their duration. And I didn't really get into that with hurricanes, but hurricanes can last 24 to 48 hours, blowing their powerful winds and falling, dropping their huge amount of rain on you. So the duration, how long does a hurricane last compared to a tornado? The geographic region, where they happen, their season, when should we expect them, their strength, comparative, greatest dangers, comparative, watches and warnings, comparative. Please compare and contrast these two types of storms. And with that, I think we have tied up the weather unit, and we can prepare to move on to weathering, deposition, and erosion.